take a look at the second half of this worksheet. So we're going to start on number 13. What is the difference between factoring and finding the roots? Oh, that's good. So we are looking for where this polynomial would cross the x-axis if we were to graph it. So we factor it, and we take the factors, and we set them equal to something. So let's say that's the graph. What do I know about that point? It's something 0. So the y value is 0. So if I take number 13 and I factor it, 4 times x plus 4, and I want to know where does it touch the x-axis, that's like saying, where does y equal 0? And that will force the equation to tell us the x value. Now, is that 4 out front doing anything useful? No, it's just in the way. Do I need it? How do I get rid of it? I could just erase it. How come? Because when I divide by 4, if you have nothing and you cut it into 4 pieces, how many pieces do you have? None. Okay, now, what if it equaled 2? Then I would have to solve it. I would actually have to divide the 4 and keep it. But because we're looking for the roots, that common coefficient has no bearing on the answers. So if you pull a 2 out of an equation and I ask you to find the factors, you need to keep the 2. But if you're finding the roots, you can just divide by 2 and forget it was ever there. Forget that the 2 happened. So in this case, x is going to equal -4. So that's pretty simple. All right. Can I divide anything out of this? I can get rid of the 6. If I divide by 6, will it change my answer? No. So I can just drop the 6 altogether. I can also pull out an x. Can I forget the x? No. So we really have 6x times x minus 2. Well, that equals 0. And this is the thing we looked at a while back. If a times b equals 0, what do I know about a or b? One of them has to be 0. So if this equals 0, what is the value of the root? No, how do we get rid of the 6? We divide it. So x equals 0. 6 times, this is really tough math. 6 times what is 0? 0. Not 2 or 8 or whatever else you were saying. Okay, so here's a hint. Whenever you pull out an x, one of your roots will be 0. Every time. Anytime you pull out an x, one of your roots will be 0. So whenever there is no constant, like x squared plus 2x and no constant, the graph has to cross the y-axis at 0. Because it's saying that the initial value is 0. Right? So if I add 4x to the third plus 3x squared plus 2x plus 0, this number is the y-intercept, right? So it has to cross right there. Because if I plug in x equals 0, that gets killed, this gets killed, and that gets killed, and we're left with 0. Okay, and our other factor is x minus 2, so x equals 2. Can they both be true? Can x be 0 and 2 at the same time? No, but one of the two is going to be the roots, right? Okay, number 15 is prime. Can we still find the root? Can we set it equal to 0 and solve it? minus 16, 9x equals negative 16. Divide by 9, x is negative 16 ninths. That was easy. Why not? I just solved for x. Well, if I plug that back in, I should get 0. Let's try it. What is 9 times negative 16 ninths plus 16? Well, those 9 cancel. Negative 16 plus 16 cancels, and we get 0. So, yeah, that's the root. Okay. No, plugging in 0 will tell you the y-intercept. But x-intercept is where you plug in 0 for y. So you're just setting it equal to 0. Okay, number 16. I'm going to draw the box. X squared, negative 16. Are there factors of negative 16 that add to be negative 6? Negative 8x and plus 2x. What does the top row share? An x. X squared over x is x. Negative 8x over x is negative 8. 2x over x is 2. Is negative 8 times 2 negative 16? Okay, we're not done. That just tells me the factors. So now x plus 2 equals 0, and x minus 8 equals 0. So x is negative 2, and x is 8. Those are the two roots. Well, you just solve. We subtracted the 2. Well, don't look at it as flipping the signs, because when we get to the harder problems, then you have 2 steps, and flipping the signs isn't going to do you any good. So what we're doing is we're getting x by itself by subtracting the 2. You'll see in a minute why the flip sign idea doesn't always work. Okay, what if I try to factor one and it's prime? Does it still have roots? Yes, but what do I know about the roots? They might be imaginary, or they could be nasty square root irrational numbers. So either they miss the x-axis, in which case there are i's, or they're irrational, in which case it's a square root and not some kind of fraction. And there are ways to find them, but we're not going to review that today. So if it says prime, the roots are unknown. You could use the quadratic formula to find them. Okay, let's look at 22. What should we do with 22? 22 on the front side. I can divide by 3. Do I need that 3 later? No, because I'm looking for the roots. If I was finding the factors, then the 3 would have to stay. So I just go ahead, divide everything by 3, x squared plus 4x minus 9, and then you could solve it. Let's do number 23 together. Can I pull out a 6? No. So you need to use the box. Six x squared and negative 6. So 6 times negative 6 is negative 36x squared. Are there factors of negative 36 that add to be negative 5? Negative 9x plus 4x. So I'll put a 9x here and a 4x there. What does the top row have in common? 2x. Well, depending on where you put these. So 2x. What is 6x squared divided by 2x? 3x. What is 4x divided by 2x? 2. What is negative 9x divided by 3x? Negative 3. Now, is 2 times negative 3 negative 6? Yes, so I must have done it correctly. Now, here's where the just switch the sign idea doesn't work. So my factors are 3x plus 2 equals 0. How do I solve for x? Subtract 2, divide 3. The other one is 2x plus 3, so my factor is going equal 0. Subtract the 3 and divide the 2, negative 3 halves. Those are my roots. Oh, I didn't see. Sorry, that's a negative, and that's a positive. Thanks. Okay, number 24. Can we alter it before we get started? Pull out an x. Do I need that x? Yes. What do I know about the x? The root will be 0. So I'm going to end up with x times something, and the root here will always be 0. And now I just need to find the other two roots. 24. So this is going to be 6x squared negative 2. So 6 times negative 2 is negative 12x squared. Oh, shoot. That 9 is supposed to be a negative 1. Otherwise, it doesn't work. On number 24, change the 9x squared to a negative 1x squared. Faulty math teacher. We don't have to redo it. So now we're looking at factors of negative 12 that add to be negative 1. Negative 4 and 3. So minus 4x and 3x. What does the top row share? 3x, good. 6x squared over 3x is 2x. 3x over 3x is 1. Negative 4x over 2x is negative 2. Is negative 2 times 1 negative 2? Yes. So my factors are 2x plus 1 and 3x minus 2. What are my other two roots? Negative 1/2 and 2/3. Does it? We're skipping a lot of steps, but does everybody understand how I got those roots? Yeah, we'll spend more time on it. Don't worry. It is, but it's more organized, and then, yeah. Okay. So this worksheet's due tomorrow. You have about 15 minutes. You should be able to finish most of it in class today. Both sides, yep.